Hello everyone. In this video, we'll be studying more on combination of capacitors. Okay. One special case that wheat tone bridge using capacitors. Okay. Uh, you will study more about this wheat stone bridge in your next chapter, that is current electricity. Here, I'll just tell you the introduction. Okay. See, you have your this combination. Okay. Uh, this is C1, this is C2, this is C3, this is C4. Right. This is C. Okay. If there are certain values of C1, C2, C4, C3, C4 are given, the condition is if C1 upon C2 is equals to C3 upon C4. Okay, if this situation is there, then no charge on C, means there will not be any charge flowing through it. Okay, or if you replace this capacitor with resistance, that means here R1, here R2, here R3, here R4. Okay, and if R1 by R2 is equal to R3 by R4, then no current will be flowing through this circuit. Okay, this is a condition of wheat stone bridge. Okay, you just accept it, right? Or if you connect a galvanometer here, then there will be not any deflection in the galvanometer if this condition is satisfied, right? This is a simple case of wheat stone bridge. Okay, this C1 C2, they are known as ratio arms. Okay, this R3 or you can say C3, this is known as known arm, and this C4 is known as unknown arm if someone asks. Okay, so this was about wheat stone bridge, right? uh, One more thing, one more problem that I would like to tell you using this. See, we'll understand this by a problem. This is a capacitor connected. Okay, here again. This is a point Q. Okay, the point P. This is 3 microfarad. Okay, 4 microfarad. Right. This is 6 microfarad. This is 8 microfarad. Right, and this you can consider it C. Okay, you need to find your equivalent potential between, sorry, equivalent capacitance between E and Q. Right, means the charge will start from here, means they are somewhat connected like this. Okay, there is a potential difference between P and Q, and they are connected to a battery. Okay, now if you see, this circuit can be seen as, this is a point P, right? Okay, here 3 microfarad is connected. Okay, this is a point if you consider A with B, right, between A and B. Okay, there is another if you consider it point C, right, the point A, the point B. We are introducing this circuit. This is 3 microfarad and this is 4 microfarad. Between B and C, there is a capacitor of capacitance C. Okay, and if you consider this point as D, or you can say Q, right? So between C and D, right, or you can say the point C, right? Between C and D there is a 8 microfarad, okay, and between B and D there is a 3 microfarad, right? This 8 microfarad, and this point is actually Q, right? This point is D, or you can say D and Q both are same. This is the point C, this is the point B. Okay. Now, if you see, this is a case of balanced Wheatstone bridge. Why so? Because sorry. This is, I think, 6 microfarad, not 3. This is a case of balanced Wheatstone bridge. Why so? Because if you see 3 by 6 will be equal to 4 by 8. 1 by 2 is equals to 1 by 2. So there will not be any charge on this capacitor. Okay, there will not be any current flowing through this, right? So this can be reduced to this form. Okay, the point P here, the point P here. Two capacitors 3 and 6, they are connected in series. 3 and 6, and sorry, 3 and 6, they are connected in series, and then 4 and 8, they are connected in series, and they both are in parallel to each other, right? So you need to find this equivalent potential. How you'll find? There's 6 and 3, they both are in series. Okay, so you will calculate their equivalent capacitance. They will be 6 into 3 upon 9, that will be, I think, 2, and then you'll calculate this equivalent potential. It will be 4 into 8 upon 12. Okay, that means 16 upon 6, that is 8 by 3. So the circuit will be somewhat like this. The point P, the point Q, okay, they both are in parallel, having equivalent potential 2 and 8 by 3, right? You can do it and find the equivalent potential. Okay, so this was the case of Wheatstone bridge, balanced Wheatstone bridge. How to solve or how to find net capacitance between 2 points. Okay, thank you.